Let's now go into an actual example where we can see how first, second, and third normal forms are applied. But right before we do that, there are some terms that we need to define. In order to define them, I'll put them on the board here as the following. One, a file in logic modeling is basically called an entity. And that is where we get the word entity relational diagram. So logical equivalencies of files are entities. Those entities have data elements, but in entity relational diagramming and logic modeling, we call them attributes. They become, in effect, attributes of a particular entity. That's why when we define non-key attributes, what I was really talking about were the elements that were part of the entity itself. So with those out of the way, let us go into the normalization of this particular database. If we were to look at this database or its equivalent, we would show it as follows. An entity is shown as a square or rectangle, and the name of this file, as we believed it to be, was orders. And the primary key was order number. And I'll notate here a PK as its primary key. All of the other elements in this particular file would end up being what I call non-key attributes. That is, they are dependent on the primary key. As we go on in this conversation, it's important to understand what I mean by dependency. Dependency means that if the key changes, my assumption is all of the other elements change with it. It basically states that the order number is controlling the values in each one of these, or a change in order number basically changes the record that we're looking at, or the occurrence of what we're looking at. We call that dependency. It suggests that all of these basically follow the order number. As such, I will show them as little boxes outside. So we'll call this order date, which is this. And for purposes of showing this, I will have some sections to put up here. This is the item number, which is here. The item name. These are all, at this point, non-keyed attributes or elements that are dependent on the primary key. So this particular group shows these elements going across at this time. And what we also have is customer number, name, and address. Let's show that now. And based on an example of the form, we will see here the only thing left is the total amount, which I will indeed show this way. So now what we have is a logical view of this form in its logical sequence, showing the primary key and all of the non-keyed attributes surrounding it. In the application of normalization, we go through a series of questions. And the first question is, are we in first normal form? Now, if you recall from my diagram before, first normal form, which I'll repeat up here, says no repeating elements. Well, going back to the form, do we have repeating elements? The answer is absolutely. Item number, item name, item quantity, item price, and item total are an occurring group. How many items can be associated with an order? The answer, many. How many? Many. So the issue becomes, I have a repeating element, which I mentioned to you before, tends to show itself in the form of a group. And that group is here. And I don't know how many of them I'm going to need. Another way of looking at it logically is that this becomes what is known as a repeating group of elements. So essentially what has happened is we have failed first normal form. Our database, if I were to implement it this way, would not be in first normal form, which means I have to have an integrity problem. And what I'd like to do for you today is to show you what that integrity problem is. What would happen if we put all of this in one file? How many occurrences would we leave for items? Suppose we had 20 items, or 10 items, or 100 items. Whatever limit we would pick for occurrences would be wrong. We would be creating an unnatural limit, which often happens. Many of us may have experienced this. Have you ever called up a company and had 25 items to order, and when you got to the 20th, someone said to you, I have to create a new order? And you'd say, why? It's one order. And they'd say, because the computer system requires it. So that's where the integrity issue becomes here. Having a situation where we have to guess at what that limit is when indeed there really isn't.